Hey guys, welcome to another episode of Let's Make a Game. We're gonna make a game like Flappy Bird. So where we left off last time is, well, I'll show you. So we had this working. So we had collision with the rotated rectangles. We had a pipe that moves, follows our mouse here. And I think the next step now would be to create basically some manager that'll handle all the pipes coming across while we play. And it'll keep creating them as in some interval, and it'll probably also lower the gap, I guess, as the harder it gets. This is already relatively tight, but we'll play around with the values when we get there. So the first thing we're going to want to do is, so right now we have this single pipe that I create here. My input manager actually relies on it, so I can move it with my mouse. So let's get rid of all of that. So don't want this. I still want to call this because we do want to initialize the pipe so that the sprite gets set up properly. Right? This is this stuff. If I don't call that, then if I try to create a pipe, oops, won't be able to do that. So we'll leave that there, and let's just remove all of these pipes. Colliding as well, we'll have to change. So let's just leave this. Comment this out. Remove everything. Input manager will no longer care about a pipe because that was just for our testing purposes. So I don't care about that. Don't want that. Don't want that. Don't want that. There we go. The manager's pretty simple, actually. I mean, we made it so that you could get the idea of what we want to do with this if your game gets a little more out of hand. Okay, yeah, we got this pipe here. Flapper's fine. Yep, there we go. So now I should be able to run the game. There's no pipe created, and I just have my plane. Yep. Okay, so let's go ahead and create. So again, instead of a single pipe that I create here now that I manage directly, I'm going to create a pipe manager. Pipe manager, and this guy will handle all of my pipes, and I don't that way I don't have to handle all the pipes in the main. I just do it all here. So let's go ahead and def Twitch pipe manager. Alright, we've got a pipe manager. So our pipe manager will need to know about what a pipe is, but so will I because of this, so I'll keep that there, but I'll put it over here as well. Yeah, this is now in the directory of pipe, so there we go. Then we'll want vector. We'll want a vector of pipe pointers called pipes. And it's pointers so that we can delete them at the end when we're done, when we want to clean them up and all that, and they get deconstructed on their own. So, pipe manager. And then this will need an update and a render. Right, because it's going to have to iterate through all our pipes, update, render. So let's do this for now. Let's include pipe manager. That was weird. Pipe manager. Let's also create a deconstructor, since we're going to want to free up all this memory before we leave. There we go. And then we have our update. And there we go. Render. Alright. For now, update and render will be quite simple. We're just going to go oh jeez. There we go. Just gonna do pipes at I dash arrow update. And same thing here, render. And what we can do is just create a new pipe here just so that we can see it. So pipe stop pushback. So we're creating a new pipe here, right? which takes a position, vector 3 position. Let's just give it 0, 0, 0 for now, just so we can see. We should at least be able to see it. It'll get updated, which I believe moves our pipe across. Yeah, it'll move our pipe back. And then our render will render. So now Twitch, we care about pipe, but we also care about pipe manager. And that's what we want to create down here. So let's do it here. And that already will create a pipe for us. So we're going to want to update that. So pipe manager update and pipe manager render. Okay, this should be enough for us for our pipe manager to now handle one single pipe, and it'll just sit there and I believe move to the left. So let's just give it like 500 so we can see it move a bit. That should be enough. There we go. It's not moving. Okay. Move the sprite by negative speed, and negative speed, and the speed is 10, speed times get delta time, and then we update our rigid bodies, which have a pointer to our position, which modifies it based on the velocity. Oh, this friction value is probably 0, so it's zeroing out. Well, our velocity would be nothing to begin with. I'm not sure why I did it that way. I don't want to do this. Yeah, this is probably some old stuff. I don't want to do this at all. Basically, now that I have rigid bodies, I want to use my rigid body to move the sprite and the entire object, right? But yeah, let's see here. So we're setting our friction to 0. Let's set it to 1. And instead of moving that directly, we're going to want to give it a force. So top rigid body dot add force. There we go. And then this will be negative speed, 0, 0. And then same with bot rigid body. So we'll add the force, and then we'll update. Yeah, I think that sounds right. And friction 1 so that we don't lose any momentum from frame to frame. And we should see it move now. Looked like it was speeding up. Oh. Yes. So we're adding the force, we're adding the negative speed, and our friction is 1, so that will never dwindle. Our update will say vel.x times equals friction, which is 1, so it'll remain the same. And then next frame I'll come back and I'll add another force. So that's why it speeds up. So really, this is what we want to do. We basically give it a push when we create it, and it'll just keep going because our friction is 1. That should now move at a constant rate. And it does, though it's quite slow, which is fine. Let's bump up the speed a bit. 100. 100 might be fast, I'm not sure. That's pretty good. In fact, that's probably still too slow. Let's give it 200. Oh. There we go. Yeah, that's better. Let's go from that, and we'll adjust as needed. So, okay, sweet. So that was pretty easy. Now when we deconstruct, I'm actually leaking memory here because I've newed and I'm not deleting anything. So I'm going to have to delete everything. So I basically just delete pipes at I. That way when we deconstruct, we can just get rid of our pipes. And then if we close, there we go. That should be working now. Also, I'm going to get warnings for these, so let's make these unsigned. Since our vector size is unsigned, there we go. No warnings. And there we go. So the other thing I would want to do is so we update, and then we want to know if the pipe has gone off the screen, because if it has, we want to then do this to it, right? We want to clean it up. Then we'll want to decide when we want to spawn the next pipe. Like if first of all, let's make this a little more exciting. Engine, oh, I need to know engine. Oops. Engine.h. screen height divided by 2. There we go. And then 500, let's make that 1500. And that screen height divided by 2 should be right in the middle, and it'll come at some point. There it is. Boom. That's pretty cool. Right, we're not doing collision again because that'll have to move over here. But that's fine. But yeah, there we go. So let's do that, and then I guess we can, like, we can do this, and this should have 2 back to back, 1500 pixels away from each other. So one, and the other one. Yep, there it is. So this is so obviously instead of this though, we're gonna want to actually cycle and create them at some rate. Maybe every time a pipe goes off to the left, then we'll create a new one, and we can just play around with that. But yeah, in this update, I'm gonna want to check to see if I want to remove this pipe, right? So what do I get here? Pipes at I. This is the static pipes, right, which I don't want to touch, but I don't have a, like, get pause. I guess it's because they're separate, but I want the pipe. Let's see. We give it a starting position. It's the pause. It gets set there. We do update pause, which. Right, this updates the position for both top and bottom and moves the sprites accordingly. But we'll basically want to get this pause back, right? Really, we care about the X. So it could be either sprite because they're both set to the same X. Obviously, the Y is what we're changing here. Okay, so let's just create a method for it to get that back. So let's go float get X. Move turn, and then we can actually, yeah, top, and then we're just changing the Y, so pause.x we should actually be able to do, and that way we can check against that in pipe manager. So here we update, and then we can check if pipes at I get X is less than 0, then we can destroy it here. So we'll want to delete it, and we'll want to remove it from our vector so that we don't iterate over it. We won't be able to remove it while we're in here though. So let's do this. Vector of pipe pointers called pipes to delete, and then we'll push it back here. Pipes at I, which is a pointer, so we can access it that way. And that way we'll go through, we'll check every pipe, and if we need to delete it, we'll add it to this array, or this vector, and then we can go through the vector and delete them themselves. So, just like this. Then we'll want to say pipes.remove, erase, yeah, pipes.erase. Oh right, we'll need to keep the iterator for it. Yeah, and this won't have the index into this guy. Okay, so how about this? Let's do this. Just ints, and then we'll just push back I, so that we know which index to remove, and then we should be able to say pipes.erase, and then pipes.begin plus pipes to delete at I. There we go. And then delete. Well, this will erase it. I'm gonna have to delete it first and then erase it. So we want to delete pipes at pipes to delete at I. There we go. So pipes at this index, which is the index we want to delete that we got from up here, and then we'll erase it down there. And that's if the x is less than 0. So if we want to see this, let's make it if the x is less than 500, and then we should see it just disappear. Oh, it's gone. Oh no, there it is, right. So if it's less than 500, it should just go away. And it didn't go away. So what happened here? Let's F9 here, make sure we're hitting it. And we can probably start that guy sooner too. Let's make this 1,000 and 2,000. So once he goes less than 500, we should hit that breakpoint. We're not hitting the breakpoint. So why is that not happening? Pipes getX is less than 500. The getX comes from the pause. The pause is a vector 3 that we keep track of. And the rigid body should be modifying that pause directly. Right? Move to, move by. We'll call these to update the top and bottom. But here we have our pause. We update the pause, and then when we initialize, we pass. Oh, we're using the. Yeah, I guess that makes sense. That we'd be using those positions instead. So really, I can't get the pause from the sprite, right? I would have to get it from the rigid body. So basically, the rigid body is moving each sprite individually. This pause, not really sure why. Well, I guess we're using that pause to create these pauses and then moving the sprites directly. But yeah, if I do this, for example, like that'll basically not change ever. Yeah. Because that position is never changing. So really I should be able to just do something like top rigid body dot get pause. We don't do that. But let's just add it. So rigid body, well, actually it gets it from the sprite, so we can just go top sprite dot get pause dot x. Is it pause? Yeah, that's sure x because it's a pause reference. There we go. That should do it. So now it should disappear when we get below 500. There it is. So we add it. If we just continue, you'll see it's gone, and there it's gone. Perfect. So now we're cleaning up properly. So let's change this back to 0. Obviously, actually, 0 might not be enough because that means, because again, the X is right in the middle of the pipe. So if we go to 0, you'll see it disappear just like that, right? So we don't like that. So let's just make it, we can just arbitrarily make it negative 100, but I think here what we can do is say pipes at I dash arrow get sure top rigid body dot get. I guess we don't have a width here or a size. Yeah, we don't have a size, so it's fine. Let's just make it negative 100. Basically, what I was trying to do is use the width of this image right at that point, so that so now they're basically the right hand side will be like over here before it gets deleted instead of right at the 0. Whatever, really doesn't matter. We could expose that, but let's just keep it simple for now. So we'll leave it there, then we push back the int, and then we remove it here. That's perfect. So okay, instead of this now, so we'll probably have 1 to start, and then we can, well, we'd have to check if it just crosses over. Then we want to spawn a new one. I think it would make sense to check if the last pipe is or just crossed a barrier. Yeah, okay. So I think we're gonna keep track of this stuff like this. So we'll have like a float x separation, I guess. Basically, this will be the separation between pipes on the x-axis, and this value can actually grow smaller as you play longer, and that would then make the game harder. We'll also be able to do something like float y separation, which will basically set up our gap for us, right? And then we'll be able to make our gaps smaller as we play as well. So let's instantiate those. What did I just call them? Separation, something, yeah, x separation. We'll make it 1,000 for now, which will give us separation like this, which we kind of saw was relatively easy. Y separation, what's our gap right now? Pipes have gaps, and their gaps start at 350. So let's make it a little bigger than that. Let's make it 500. And then we'll have, let's say, a min, I guess, which will be 350. Can our pipes currently change the gap? No. So let's do a void set gap for gap, so we can change this guy directly. The speed, I guess we can make it faster, or we can make them come more frequently. Let's just do the gap for now. We'll play around with it and see what we want to change. Okay, set gap. Where did I put that? Right after this guy. Set gap, float gap. Alright, can't call it gap. Underscore gap. Goes underscore gap. There we go. What's wrong with that? G's undefined? Yeah, I think it's just doing. Yep, there we go. Okay, so that gap, where do we use it? We just use it here in update pause. So if we change the gap, we'll have to update the position. So we'll call an update pause in order to have that new gap be reflected here with these positions, and then we should be good to go. So now we'll create these pipes, and then we can say pipes, let's say just say pipe at 0 since we just pushed one back, just a test. Dash arrow set gap, Y separation, and let's make this one like Y separation divided by 2, just to see the difference, right? So the first pipe should have a rather large gap, yep, and the other one should be half that, which is much smaller. There we go. So then, yeah, that's kind of an impossible gap there, but that's fine. So now we can change the gaps at will, which we'll do that as well. We'll have to have some sort of tracker of like difficulty or something and use that to scale these values. But for now we can start them like this. So before I forget though, we have to add the collision again. So we can do bool check collision and take a player in, right? Or a flapper rather. Check collision with a flapper. How about a const flapper reference? Fancy here. Flapper. So we'll do that. And the reason I do it this way instead of having the collision out here is because I don't want to have to iterate through anything here, right? So as I update everything, then I'll check for collisions, and then I can still print this out for now, and then otherwise, or once we have our game manager or whatever, we can end the game and show your score. But for now, basically this is what I'm going to move over. And then we'll do pipe manager dot check collision and pass in just my player, and it'll go in as a const reference. And then I can say bool is colliding is equal to that, and then the rest of the code will stay the same. And here, our check collision is after a render. Check collision, const flapper reference flapper, and basically just return this. So if rigid body is colliding, instead of player it's flapper, and instead of pipe it'll be, we'll have to iterate, right? Yeah, so we'll have to get a bool is colliding equals false. Assume we're not colliding unless we're told otherwise. We need a rigid body, so we need to know about that. Engine math, right? Math.h. Is this one has a rigid body in it? Math.h. No, where's the rigid body? Correct? No. Where does our rigid body live? Rigid body.h. Oh, physics, probably. Yeah, physics. Whoops. Oh, I forgot where I put some of these things. Don't need that, don't need that, don't need that, don't need that, don't need that. There we go. There we go. So we, instead of math, now we want physics. Rigid body.h. There we go. So include rigid body so that we can do that. This is a static method, right? Static bool is colliding. So we can call it directly like this, but obviously pipe doesn't exist. So instead of this, also we'll say is colliding equals, and this will be within a for unsigned int I equals 0. I is less than pipes dot size I plus plus, and then check if we're colliding. The flapper. What's wrong here? Oh, I guess I can't call. I guess it's not a const method, right? Get rigid body, because I could change it. So let's just not make it const. That's fine. Really though, I think we should be making the method const, since we shouldn't be able to change it. Although if we want to sometimes, then we shouldn't make a const. So let's just not make it a const reference instead. And here I can just say pipe pointer pipe equals pipe set I, just to use pipe instead, and it'll still have to be pipe. Sure. I can just do pipe set I. No need for that. And then pipes set I, and then this or boom. What's the problem here? Pipe set I. Special must have class type. What are you talking about? Declarations. Oh, this should be a bool. And this guy, expression must have class type. Oh, yeah, whoops. Sure, there we go. And then we don't really care which one we're colliding with, right? We just want to know that we collided with a pipe. So if we're colliding, then just break. Return is colliding. There we go. So now from our main, our twitch.tpp, that should be happy. And colliding should now work with both pipes. So they're colliding. And these guys, we are also colliding and colliding. There we go. Straightforward. Okay, now the pipe should actually start to do stuff, right? So let's see. How do we want to do this? We can create the first pipe here, and then we'll have to check. Yeah, we'll have to check when this crosses the 1000 mark barrier. We'll want to kick off another pushback. This can be like our starting position, right? Or starting X, 1500, because that's just off the screen, and they'll come over on their own. The height, oh yeah, that's right. The height can also fluctuate, right? It could be anywhere. Well, it could be anything between certain range. So for now, let's just do this instead. So I'll create a private method called create pipe, and it will handle everything for us. So here, I'll just do create a pipe. There we go. And then, oh no. Oh, pipes manage, pipes up pushback. New pipe, vector 3, 1500, engine screen height divided by 2, 0. There we go. So now we can modify how we create pipes in one method, and we just call that guy. And there we go. So now we only create one pipe. That's fine. Okay, so we have to decide when we want to create another pipe, right? Now the only problem I see right now is that basically when the last pipe is crossing that X separation threshold, like that check can't be an equals check because we're moving, like we're multiplying everything by friction and by engine delta time, right? It's all floats, so I can't do an equals comparison because chances are I won't hit that. If I do a less than, then as soon as it crosses this 1000, it'll just keep creating. Oh no, it won't. No, it won't, because yeah, that's right. So if I can, so here's what I'll do. Basically, my concern was that if I cross the 1000 threshold with a certain pipe that I'm checking for, then I'll just continuously create pipes because it'll be less than 1000, and I'll have to keep track of whether I created it and all that, but that's a lie, because I can just do this. Basically, if I is equal to pipes.size minus 1, then we know we're checking the last pipe, meaning the rightmost pipe, and I can just check for this guy. So if pipes at I dot dash arrow get x is less than x, it'll be engine screen width minus x separation, because we're talking about 1,000. X separation. There we go. Talking about 1,000, I guess, pixels now from the right-hand side. So if we've crossed that threshold, then we'll create a pipe, and that'll get added. So then the next time we check, this will now be the new pipe, and its x will be greater than 1,000. So that should cycle. Actually, yeah, that should cycle beautifully. Let's give that a shot. So once this crosses some threshold, 1,000. There, that was collision, but there it is. There's a new pipe, and 1,000's a lot. Let's just say 100, and we'll just see a bunch of pipes, basically. Because once you cross the 100 pixels here, it'll create a new one over here, and there it is. And they're getting cleaned up at the end, and there we go. This is like a real game now. This is pretty sweet. Our gap, I think we're not setting it, right? So it's still 350. And I could just keep, this is going to go all day. This is the best. And then if you see what I mean, like this, we can just start lowering the number as we play longer, or maybe as our points increase, or whatever we decide. And then it'll just start creating them like crazy. Oh, this looks similar. What happened there? Let's make it 1. If we make it 1... Oh, I guess there will always be... Yeah, right, because I created them so far off the screen. Let me change that. Really, I should only create them at engine screen width plus some value, right? Because if I don't add it, so this should just create them every frame, basically, which might be a problem, but yeah, I think we're stuck creating them. Let me make this 100 again. Yeah, see what I mean? So if you can see them basically teleport in, right? And that's a problem. Let's make this 250. Maybe that should be our min. We'll keep track of maybe a min and max, and keep it within those values. Basically, there'll be a max difficulty because otherwise it'll become impossible. But yeah, so this is where we want to add, and again, here's where I really would like to add the width of the image. So you know what? Let's just do that, and I can do that here. Use that here as well. So minus pipes at I dash arrow get width, and then plus pipes. Maybe I can just make it so that this x will add the width to it after, right? Because this is when we're instantiated, right? So I'll need a get width for sure. So let's do that. I have a get x, get width, and turn top sprite dot get size dot dash arrow x, or actually I want the size times the scale, right? X times top sprite dot get scale dash arrow x. There we go. So now I should be able to use that for spawning. So they'll spawn, or not for spawning, sorry, for clearing, which means they should be clearing as soon as we get to the left. Oh, and this will be width divided by 2. And that's because the X position is right in the middle of the image. So the width, I mean, again, it's all off screen, so it's not a big deal, but it's really here that we care about. Because when we create the pipe, we'll want to set the position. Yeah, here. So I'll give it a pause. I can give it the position plus vector 3, and then I can just add the top sprite dot get size dash arrow x times actually I should be able to call my method, right? Oh, we're in a constructor. I don't think you're supposed to do that. Let's try it. Alright, well, let's just try that. So now they should be creating right off. Yeah, there. And as you can see, it's instant, right? And that separation, yeah, that's much better. Yeah, I guess you can call methods in constructors, so I might be thinking of something else or something really old. Okay, so our pipe manager now creates them properly. We'll need to, yeah, let's set up the mins and maxes now, okay? So we'll have our x separation, then we'll have our float min x separation. We'll have our y separation, which is a gap, and then we'll have a float min y separation. And then we can have a float min y spawn y, float max spawn y. There we go. That should be everything, I think. So min x separation will be it's 250 right now. We can make it 200, I guess. We'll have to play with that. Min y separation is our gap, and we're gonna go with the value we set, 350, or maybe 300. I think we said we could go a little lower, so let's try 300. And then min spawn y, let's say I don't know, 100, and max spawn y. In this case, we'll have to be engine's screen height. Oh, wait a minute. Engine screen height minus 100, and this will be, wait, this will be 100. Might have to go those backwards, but we'll check. Okay. So we can start we can choose to start these x separations and y separations at a larger value. So we say 1,000, and 1,000 might be a lot. Let's say 800, and our y, let's say 500 to start. So when we create, we can do pipe pointer pipe equals new pipe, and then we can pass this stuff along. And then at the end we'll do pipes.pushback pipe, but this way we can call methods on it now, right? So we can say pipe dash arrow set gap y separation, and then here we'll have to say float spawn y equals rand mod, and we'll want a value. We'll want to value the size of the difference. So max spawn y minus min spawn y, and then we'll want to add min spawn y. Right? So we take the difference, and like let's say it's 5 and 10. The difference is 5, so we'll generate the value between 0 and 5. Well, it'll include it 0 to up to 4, right? And then we'll add the 5 that we wanted to start with. So we'll get a value from 5 to 10, which is what we wanted. Something's wrong here. Integral or unscoped enum type. Rand. Is this not how you do it? Rand. Yeah, it's just an int. Mod. Flow. Oh yes, of course. Int. Yeah. I mean, I might as well just make them ints then, right? That's better. So we'll get a rand, and I guess we have to call srand at some point. We'll do it here. There's a way to do it. Srand time dot get time null or something like that. Let's just say srand 1 for now. Well, let's see. I think we can just do... Yeah, okay, we'll need to include time.h and then do srand time, pass it null. There we go, that's how you do it. So basically this will make sure that we have a truly random, or as close to truly random as possible, or at least close enough seed. So now this will be different every time, and it won't be the same numbers every time we run the game. Okay, and then we'll use spawn y instead. Oops. 0. What's the problem here? Give it a vector 3 pause. What's complaining about? Expected a semicolon. Oh, I probably kept, yeah, there we go. Okay, let's give this a shot and see what happens. And some warnings, we can go back and fix those later, but... Okay, that's too low, we know that. That's too high. Something in the middle, again, that's too high. That's better. I think the range is too high. Our min and max are way too big. So let's go back. That's fine. Let's say our min is 500. Basically, we want it to be the same distance from the top as it is from the bottom, right? So apparently that's still too much. Yeah. Or maybe the gap is just too big. The gap, yeah, you can see the gap might also be too big. Well, I mean, let's see, let's make it. Well, what's our height? Our screen height is 768, so between 500 and 768 minus 500, that doesn't really give much room. So maybe, yeah, our gap is just damn large. Let's go 400 and see. Even that's too high. Yeah, that you can't even see. Are we calling setgap? Well, no, we must be, yeah. Let's make this 100. And we're calling setgap y separation, so. Yeah, that's too high. That's too high, too. That's way too high. That's definitely less than... Yeah, I might have these backwards like I was thinking. Let me think. So spawn y is a random value between 0 and max int, and we mod it. Oh, are we modding it to this? That might be doing something weird. Let's do this. Generate a random number, modding it to our max minus our min, which will give us a positive number, which is the difference, and then we'll add min to it. Maybe, I don't know what the order of operations is there, but it looks a little better. That's still too high, way too high. Max minus min plus min. Our 0, yeah, okay, our 0 must be coming from the top. So our min our min is 500, our max is screen height minus 500, which is 768. Really, it should be a tiny... So if this is... Let's put a calculator here. 768 minus 500 is 268. We'll get a value between 0 and 268, and then we'll add 500 to it. Yeah, that's wrong. Basically, if we get 268, if we get the highest number from this and we add our min back, then we'll get that high number again, right? Maybe I have something wrong here. So max minus min again. Max is 768 minus 500 minus the min, which is 500. That's a negative number. That's really small, which is really high. Wait, how is max? Our max is a big number and our min is a small number. Well, no, actually that's not true. Because our max. Sorry, yeah, I've got these numbers weird. So if our min is 500, then our max spawn y is, yeah, so 500 is simply too large. Right? Yeah, I don't know why our min is 500 is already too big. So if 768 is our max, means that 384 is our min, or our mid. So really, if we want to go anywhere between, let's say, 284 and 684, oh no, 284 and 484, then we'll want 284 and 284, as long as they're the same, and it'll be 768 minus 284 will be our 484. Yeah, there we go. That should give us some more reasonable outcomes. Yeah, that's better. That's better. Yeah. So I just want a slight fluctuation. Obviously, that's probably not enough, but actually, that goes pretty low. I think I'm happy with that. And that means if it goes that low, then it'll go that high on if you flip it on the x-axis. So yeah, I think I'm happy with that. Obviously our gap will have to go up. So let's move our gap back up to, what is it, 500 I think I had it at? Which is huge, but that'll get smaller. I don't know if that'll be too much on one side though, based on the random numbers. Well, I mean, I think I'm fine with that. We can always tweak it later if we see something weird, but yeah, I think I'm fine with that. Alright, sweet. And collision still works. Yep, everything still works. Awesome. So now we have that. Okay, so we'll have to be able to keep track of like score, and I guess Pipe Manager would do that because, well, we can count every time a pipe crosses the middle, basically, then we'll count a point, right? Because or we could see it, we could do it both ways, right? We could think about a pipe crossing the middle boundary and adding a point, or we could do the player knowing that it got through a pipe somehow. I think the first option makes more sense. But maybe I'll leave points till we have a game manager set up and all that. I think for now, I think this is really what I wanted to get done this video. It's just having them go. What I could do is keep track of, here, let's do something real quick. Let's keep track of total pipes that were spawned. Total pipes will start at 0. And basically every time we spawn a pipe, we push back and say total pipes plus. And now we can check, actually we could probably do it here. So every time we create a pipe, we add to our total pipes, and then we can check like if total pipes mod 10, mod 10 is 0. So if we're a multiple of 10, then we can, well, let's do 5 just to see it quicker. Even 5 might be a lot. Let's try 2. So basically every 2 pipes, we can increase and decrease the X and Y separation. Actually, that'd be it. Yeah, just these 2. And also, we probably want to know So we have x and y, min x, min y. We'll want like a x or diff. No, x separation speed and y separation speed. We basically want to be able to tweak how fast, or yeah, how fast this game gets harder, right? And that'll be after these guys. X separation speed. Let's say every interval, whatever we decide. Right now we have set to 2. We'll decrease the separation by, let's say, 10. Let's do 10. Subtract it at the end, and the y separation speed. We can also do 10. So it should get like gradually closer and a smaller gap as we go. And then obviously we'll have to check min and max here, right? So if x separation is greater than x separation, or min x separation plus x separation speed. So if our value is still greater than our min plus our speed, then we know that we can subtract our speed without crossing the min. So x separation, oops, x separation minus equals x separation speed. And we can do the same with the y. So if our y separation is greater than our min y plus our y speed, then we can safely subtract speed from separation without crossing the min y. And if subtracting the speed would cause us to be below this, then this won't happen. And yeah, that should be enough to basically make the game harder. So every time we spawn a pipe, so let's see, every time we spawn, so in this case it would be every 2 pipes, we should see it get faster. And this might take some time to really be noticeable, but because it's every 2 pipes, I can make it every pipe really for the sake of this and make the speeds a lot bigger. It's probably already noticeable though, really. But yeah, basically the player would be playing basically like I am right now, and they wouldn't really think that things are getting worse or harder for them. It's not that noticeable. Actually, already I think the gap, you can tell a little bit, but because it's such a... And again, for the player, it won't be this fast, right? Like, you can already tell the pipes are getting spawned before the other pipe is off the screen, right? Like, you can tell it's getting faster. Kind of like that. But yeah, it could be even more subtle, right? It doesn't have to be every 2 pipes. It could be every 10 pipes or whatever we decide. We could even muck around with the speeds too, right? And make them the pipes just faster in general, instead of more frequent. I think that would add an extra dimension of, you know, of difficulty. But yeah, already it's, you know, you kind of look at when this pipe gets spawned, kind of where the previous pipe is on the x-axis, and you can see it's inching closer and closer to the right hand side of the screen. Yeah, I'm happy with this. This is pretty good. And then it should never cross our mins, so we should always have a playable game. Obviously you can't lose yet, like you can collide just fine, but that'll all come when we add a game manager and keep track of game states and all that. We'll add all those things at that point. But yeah, I think this is pretty good. I think I'm going to leave it here today, guys. Hopefully, yeah, I like this a lot. It's already, you can see it's already getting smaller, the gap, and you're already like, okay, I have to be a little more careful. The one thing that our game kind of has a disadvantage on is that we have a big plane as the Flappy Bird, which is quite kind of wide, right? So you have to be a little bit more careful, basically, compared to the original game. You have to be a little more careful here, because you have such a wide collision box. Like, our tail is waving up and down a lot, and there isn't really much room for error. Or rather, there's more room to consider when calculating when to flap. Yeah, this is already getting much faster. This is pretty good. Okay. So next time we'll look into actually tracking points and showing them on screen and being able to keep track of your state. That'll probably be the last video actually in the series, because at that point we'll have a fully functional game where you can kind of like press space to start or whatever. Go ahead and start. You keep track of your points. We could even have a little leaderboard text file that we write to or something. But yeah, I'm really happy with this. So, hope you guys enjoyed that video, and I will see you next time.